The last time this happened, 4,000 people died in floods, droughts killed crops across 3 continents, and insurance companies paid out more money in a single year than they had in the previous decade combined. That was 1997. What is forming right now in the Pacific Ocean is tracking ahead of that event, faster, warmer, and with computer models showing nearly 100% agreement on where it ends up. This is not a forecast. It is not a projection with error bars attached. The ocean is already doing this. The water temperatures are already there. The atmospheric response is already beginning. 97%. That is the probability NOAA has assigned to a strong El Niño forming by early summer 2026. 63% chance it becomes very strong, what some researchers are already calling a Super El Niño. Before this video ends, you are going to understand what that number actually means for hurricane season, for the winter coming after it, and for the specific way this event will reach into your daily life, in ways that almost no mainstream coverage has explained clearly. 0 to 30, 1 to 30. The promise. Here is what most coverage gets wrong about El Niño. It treats it like a weather event, a single season of rain or drought that comes and goes. That framing is accurate the way describing a wildfire as a heat source is accurate. Technically true, completely insufficient. What a Super El Niño actually does is restructure the entire atmospheric circulation pattern of the planet simultaneously. It does not change the weather in one place. It rewrites the rules for every major weather system in every hemisphere at the same time. By the end of this video, you will know exactly why Atlantic hurricane season is about to get significantly quieter, and why that is not entirely good news. You will understand what the southern United States is about to face this winter, and why the Northeast is sitting in the most dangerous position on the map. And there is one piece of this story that almost no one is talking about yet, a detail buried in the subsurface ocean temperature data that changes the severity calculation completely. We will get to that. Stay with this, start with the ocean, because everything else follows from what is already happening 400 meters below the surface of the Pacific. 1:30:4, first value block. El Niño begins underwater, not at the surface, underneath it. In the equatorial Pacific, there is a thermocline, a boundary layer where the temperature drops sharply from the warm surface water to the cold, deep ocean below. Under normal conditions, trade winds blow from east to west across the Pacific, pushing warm surface water toward Australia and Indonesia, and allowing cold, deep water to upwell along the South American coast. The thermocline slopes downward from east to west. When El Niño starts, those trade winds weaken. They can even reverse. And when they reverse, something called a Kelvin wave forms, a massive pulse of warm water that travels east along the thermocline like a slow ripple across the entire Pacific basin. That Kelvin wave is already in motion, right now. And the temperature anomaly driving it is not subtle. Subsurface water temperatures in parts of the eastern equatorial Pacific are already running 3 to 4 degrees Celsius above normal. Not surface temperatures, subsurface. That matters because subsurface warming is the fuel supply. Surface temperatures respond to wind and cloud cover and can shift quickly. Subsurface warming is committed. It is physically in the system, and it is moving east. Australia's Access climate model, one of the most respected ensemble forecasting systems in the Southern Hemisphere, is showing nearly 100% of its model runs, pointing to a very strong outcome. That kind of model agreement almost never happens this far in advance. When models agree at that level, it does not mean the forecast is guaranteed. What it means is that the physical state of the ocean has already removed most of the uncertainty. The range of possible outcomes has collapsed. Here is what the westerly wind bursts are doing that most coverage skips over entirely. They are not just weakening the trade winds, they are actively accelerating the Kelvin wave. Every burst of westerly wind adds energy to that pulse of warm water moving east. Multiple bursts have already been recorded in the past several weeks. Each one is a fingerprint of the atmospheric response to the sea surface warming, and each one feeds back into the ocean to push temperatures higher. This feedback loop is why the event is developing faster than the 1997 El Niño did at the equivalent point in the calendar year. In 1997, the ocean was warm. Right now, it is running ahead of that benchmark. Stay with this past the 4-minute mark. Because what happens to hurricane season when a Super El Niño peaks is not what most people expect, and the mechanism behind it is the part that changes how you should be thinking about the rest of this year. 4:7 days, second value block. Atlantic hurricanes need 3 things to intensify: warm sea surface temperatures, low atmospheric wind shear, and a favorable moisture environment. El Niño attacks all 3 simultaneously, but wind shear is the most direct and most powerful mechanism. When El Niño is active, it shifts the position of the jet stream and strengthens upper-level winds across the tropical Atlantic. Those upper-level winds create shear, a difference in wind speed and direction at different altitudes that literally tears developing storm systems apart before they can organize. The result is predictable and documented across every major El Niño event in the satellite era. Atlantic hurricane seasons during strong El Niño years produce fewer storms, fewer intense storms, and a lower probability of any individual storm reaching Category 4 or 5. NOAA's current forecast for the 2026 Atlantic season reflects this directly. 8 to 14 named storms, 3 to 6 hurricanes. That is significantly below the long-term average of 14 named storms and 7 hurricanes. But here is what the below-normal forecast obscures. Fewer storms does not mean no storms. Every catastrophic Atlantic hurricane season in modern memory, Andrew in 1992, Hugo in 1989, occurred during years with some degree of El Niño influence. One storm, one landfall at the wrong location. That is all it takes for a below-normal season to become the most expensive weather event of the year. The forecast is for the season's aggregate output, not for the individual storm that hits your coast. And while the Atlantic quiets, the Eastern Pacific does the opposite. El Niño supercharges Eastern Pacific hurricane development, warmer water, lower shear, more favorable atmospheric conditions, the same physics that suppress Atlantic activity actively accelerate Pacific storm formation. That is not a concern for the continental United States in the same direct way that Atlantic storms are. But it is a concern for Hawaii, for Mexico's Pacific coast, and for the moisture plumes that Pacific storms feed into the southwestern United States during landfall events. The 1997 El Niño produced multiple record-breaking Pacific hurricanes. Linda reached sustained winds of 185 miles per hour, a Category 5 by a significant margin. Pauline killed more than 200 people on Mexico's Pacific coast. Reward for staying here. The El Niño suppression effect on Atlantic hurricanes is real and well documented. What is less discussed is that it shifts risk, not just removes it. The risk concentrates into fewer, more erratic storms in the Atlantic and an overactive Pacific season simultaneously. Event 7, Juradoctors 10. Third value block. The hurricane season story is the one making headlines. The winter story is the one that will affect more people. And it is developing in a way that almost no coverage has mapped clearly. El Niño's influence on North American winter patterns is one of the most robustly documented signals in climate science. The mechanism runs through the same jet stream disruption that suppresses Atlantic hurricane activity. Only in winter, the consequences are measured in ice, floods, and temperature anomalies that persist for months. The southern tier of the United States, from California through Texas, across the Gulf Coast through the Carolinas, faces a significantly wetter and stormier winter during strong El Niño years. The jet stream shifts southward, directing a parade of Pacific moisture systems into regions that are not equipped to absorb it. This is not a prediction that it will rain more. It is a prediction of a specific atmospheric regime in which severe weather, flooding, and ice storm risk are all elevated simultaneously across the same geography. The 1997-98 El Niño produced rainfall totals in California that were measured in feet. It produced flooding across the Gulf Coast that killed dozens and caused billions of dollars in infrastructure damage. It produced a series of ice storms across the southeast that paralyzed cities for days. Now apply those analogs to 2026 to 2027 with an event that is tracking ahead of 1997 at the equivalent point in development. The northern United States gets the opposite signal, a milder than average winter. The jet stream displacement that sends storms into the south pulls cold air away from the northern tier. Minnesota, Michigan, the Dakotas, they tend to run warmer during strong El Niño winters. That sounds like good news until you factor in the Northeast. The Northeast sits at the collision zone between the anomalously warm northern pattern and the anomalously wet southern pattern. That collision zone is exactly where the most dangerous winter weather forms. Ice storms, freezing rain events that coat roads, bring down power lines, and strand communities for days. They develop precisely in the thermal gradient between warm and cold air masses. El Niño does not just bring winter weather to the Northeast, it manufactures the specific conditions that produce the most destructive kind. Here's the unexpected detail that rewards everyone who has stayed this long. There is a lag in El Niño's atmospheric influence. The ocean warms first, the atmosphere follows, which means the strongest winter impacts typically arrive not during the peak of the El Niño event, but during the 6 to 12 months after the sea surface temperatures begin to decline. The winter of 2026 to 2027 will not be the only winter affected. The atmospheric memory of a Super El Niño extends into the following year's patterns. The full impact plays out across a multi-year window, and that is something the one-season forecast framing consistently fails to communicate. 10 to 12 serve fourth value block. The 1997 to 98 El Niño is the reference point for this event, and that comparison does not work the way most coverage presents it. 1997 is typically cited as proof of what a Super El Niño can do. Sea surface temperature anomalies in the Niño 3.4 region reached plus 2.3 degrees Celsius above the baseline. The global average temperature for that 12-month period was the highest ever recorded at the time. The economic damage from associated weather events, floods in Peru, drought in Indonesia, wildfires in Malaysia, ice storms in the United States, crop failures across sub-Saharan Africa, was estimated at approximately $33 billion globally. 4,000 people died in El Niño-related weather events in that single year. What is different now is not just the ocean temperature, it is the baseline. The 1997 El Niño sat on top of a global ocean that was already warmer than any period in the previous century. The 2026 El Niño is developing on top of an ocean that is already running historically warm before the anomaly is even added. Think of it this way. 1997. El Niño was a fever added to a body already running slightly warm. The 2026 event is a fever added to a body that has been running hot for years before the illness arrived. The Niño 3.4 region, the central measuring area for El Niño intensity, is already showing anomalies approaching the thresholds that define a very strong event. And the Kelvin wave carrying subsurface heat toward that region has not yet fully arrived at the surface. The access model ensembles showing nearly 100% agreement on a very strong outcome are not projecting from a standing start. They are extrapolating from an ocean state that is already deep into the development process. The ensemble agreement is so high because the physical state of the ocean has already committed the atmosphere to a path. This is the piece that makes the severity calculation different from any previous event in the modern observational record. El Niño severity has historically been constrained partly by the background ocean state. That constraint has moved. The floor has risen. 12 Sigerner, 14 to 30. Build to pay off. Pull back now to the full picture. A super El Niño is not one thing. It is not a hurricane season, or a winter pattern, or a drought in one region. It is a simultaneous restructuring of global atmospheric circulation. And every regional signal discussed in this video is a branch of the same root cause. The Atlantic hurricane suppression is real. The Eastern Pacific overactivation is real. The wet and stormy southern United States winter is real. The ice storm risk in the Northeast is real. The elevated flood risk across the Gulf Coast is real. These are not separate events. They are expressions of a single planetary scale weather regime shift. That is what the 97% formation probability actually means. Not that a weather pattern is changing, that the entire structure of how the atmosphere organizes itself over the Pacific, and by extension over every ocean basin it connects to, is locking into a new configuration for the next 12 to 18 months. The warning window for a CME is measured in minutes. The warning window for a Super El Niño is measured in months, and those months are already counting down. The physical state of the ocean has already been measured. The model agreement has already been calculated. The analog years have already been studied. What is missing is not information. What is missing is the translation layer. The step between the scientific forecast and the practical decision that a person, a municipality, a utility, or an insurance company needs to make before the season begins. California needs to be preparing its reservoir overflow protocols now, not in November when the atmospheric river events begin arriving. The Gulf Coast needs to be assessing flood infrastructure capacity now, not after the first major winter storm system stalls over the region. The Northeast needs to be pre-positioning road treatment supplies and utility repair crews for ice storm scenarios, not sourcing them in real time during the event itself. These are not extreme measures. They are the same kind of pre-positioning that works for every other predictable high-consequence event. The difference with El Niño is that the lead time is enormous compared to almost any other natural hazard. The warning exists. The question is whether the response catches up to it. 1430, 16. Close and CTA. The last Super El Niño left $33 billion in damage and 4,000 deaths across a single year. It happened on a cooler baseline ocean with less atmospheric energy already in the system. This one is developing faster, tracking warmer and carrying more subsurface heat than its 1997 predecessor did at the equivalent point in its development cycle. Nearly every major modeling system on the planet agrees on where it ends up. The physics will resolve, the sea surface temperatures will peak, the winter patterns will arrive on schedule. The question this event has already answered, the one that every climate scientist watching this data will be updating their models to reflect, is how much warmer the baseline has to get before a Super El Niño produces consequences at a scale that the response infrastructure is not equipped to absorb. That answer is not in this video. It is in the next 12 to 18 months of data being collected right now by the same buoys and satellites that detected the Kelvin wave already moving east across the Pacific. If this changed the way you understand what a 97% probability actually means, not as a weather forecast, but as a systems event with a real timeline and a real response window, share it. The people who need to understand this are the ones who do not yet know the clock is already running. Subscribe if you want to understand the next event before the headline tells you it already happened.